My name is Kevin Jones. I'm a global solutions architect working for NGINX business unit, now part of F5 Networks. I've worked for NGINX for about 4 years, a little bit over 4 years. Previous to working at NGINX, I actually worked for yellowpages.com as a site reliability engineer, where I actually managed NGINX there. So I love the product so much that I came to work for the company. And so today I'm going to be talking about specifically API delivery, how to actually architect NGINX as an API gateway, and how you need to kind of look at some of the features and functionalities of both the gateway and what we call the management plane. And I'm going to kind of go into those differences. And everything here is just really to give you guys, spark some interest and kind of get an understanding of what you guys are trying to accomplish and hopefully help guide you in the direction that you guys are trying to go from an API perspective. So this is like a rough high look at the agenda. First, we're going to talk about why APIs are kind of growing in the industry and why you need to manage them. We're going to talk about the common API deployment patterns that we see in a north-south type of deployment. And then we're also going to take a closer look at how that works with EastWest Traffic and with some of the more cutting-edge application architectures that we're starting to see. Then we're going to recap those patterns, and then we're also going to just talk about what can NGINX do for you. For people that don't know how NGINX kind of fits into that piece of the puzzle, we'll give you guys an overview of kind of the solutions that you have at your disposal if you decide to use NGINX in this solution. And so first we're going to talk about APIs. So I think you guys can all agree that APIs have kind of skyrocketed over the last 5 to 10 years drastically, especially with the increase of mobile applications and web browsers. And there's a lot of reasons why companies are building APIs. Some are internal, some are external. If it's an internal API, a lot of times it's to help break down silos in the organization and actually allow teams to work at a quicker pace and expose their services to each other and kind of just unlock the potential that they have internally in the organization and just increase that collaboration between developers. Or maybe they want to provide a standard interface for communication in their microservices environment, right? They might be having monolithic apps and they're trying to break those down, and they're finding that you kind of start getting all these different rogue companies or rogue teams, I should say, that are trying to develop APIs, and then you just need to standardize on one. And so creating an interface that makes sense for that deployment is a solution. Or maybe it's an external API, and that's core to the business of that company, right? So a lot of companies are building their entire revenue stream on APIs, and we'll talk about that in a little bit. But or maybe it's just you have a mobile application, or you have external partners or customers that need to be able to consume those APIs. And so these are all kind of like things that we're seeing in the industry. I think this makes sense to you guys. And over the years, we can see since 2005, the programmable web has been tracking these externally available APIs. And over the past 4 to 5 years, we've seen about 200 new APIs per month consistently being available, publicly exposed. And so with the increased amount of APIs, you're seeing an increased amount of communication. And there is more of a time now than ever to have some way to manage and control access to those APIs. A few companies that stand out that we've worked with, one being Salesforce, which 50% of Salesforce revenue actually comes from their APIs. And so it's critical that their APIs are performant, controlled, secure, and basically they don't have any issues with the uptime of those APIs. And then if you look at something like Expedia, where almost 90% of their revenue is exposed using those APIs, they cannot afford any issues with their API infrastructure. And I think it just depends on the company, but there's always an impact to not having those APIs available. And when it's revenue involved, it's even more and more important, right? And about 40% of NGINX Plus instances, according to a survey that we did in 2017 and 2018, are actually deploying NGINX Plus as an API gateway in some sense or another, right? Whether it be access control or authentication authorization or rate limiting or protecting from a DDoS perspective, majority of services are being controlled or protected as an API gateway. And so first, I think it makes sense to really talk about I call it the elephant in the room. What is API management and what is API gateway? A lot of companies claim that they're an API gateway and vice versa. And it's kind of two different synonymous terms, but they're kind of often used right together. But really API management is doing more of the policy definition, right? It's actually providing the control plane, right? Pushing configurations, providing a portal for developers or for users to manage the APIs, the publishing of those APIs. And then also providing visualization and some kind of consumption or performance monitoring solution as well. And so you can think of it like the single pane of glass that sits on top of your API infrastructure. And then the API gateway is doing more of the heavy lifting, right? It needs to be lightweight and it needs to be portable, easily distributed, especially in like multi-cloud and with containers now, right? So it needs to be very lightweight, but it also needs to do the heavy lifting. It needs to be the one that actually makes the decision of what's passing through it to the application, who's getting access to what APIs, how many requests per second that they're able to access, how many connections of client connections can it open? Does it need to keep alive? So all of the heavy stuff that a gateway or a proxy should do needs to be handled at that layer. But at the same time, it needs to be lightweight. So it's kind of a catch-22 and do all the request processing as well, right? And so there's various characteristics that and this is all debatable, and I would say that these are kind of the top ones that stood out to me when I was creating this presentation as characteristics that you should look out for from both an API gateway perspective and an API management perspective, okay? So from an API gateway perspective, the gateway should protect your APIs, right? No matter what. That's the main, I would say the most primary reason that we see people installing an API gateway is to control access, whether it be rate limiting, connection limiting, access control, based off of IP addresses or ranges or headers or whatever you're trying to protect access based on some kind of variable. And then you have the authentication and the authorization, right? It needs to actually go and say, hey, like what client is connecting? What do they have access to? How often can they access it? What level of authorization do they have based on some kind of authentication service that you have? It definitely needs to be multi-cloud support. In this day and age, you can't really rely on one cloud. You can't really rely on just having everything in a data center. So it needs to be universal in that sense. You need to be able to publish it on-prem or on the cloud or maybe multiple clouds. So having some kind of like solution that can be deployed on Linux is a great fit. And then it should provide you some kind of insight, both either by logging or by some kind of REST API, or both. And then for the actual control plane, you need to be able to define and publish APIs from that management plane. You need to be able to alert, right? If something's wrong with the API, if someone's doing a denial of service on your APIs. And at the same time, you need to provide high-level monitoring and analytics, like performance monitoring or consumption monitoring and analytics of the consumption, and provide that to your users or your customers. And then it should have some kind of onboarding or documentation method where someone can actually, like a developer can log in and say, hey, here's my Swagger. These are all my endpoints. This is what it does. This is how my API works. And here's the documentation so that in case you need to know something, you can have one single pane of glass for that. And then also it should be customizable. You should be able to make your own dashboards and do some kind of level of fine-grained monitoring of your APIs. And so, here at NGINX, we kind of see it all. We work with lots of different customers. We work with lots of different types of customers. And I think the one thing I'll say is like none of these patterns are like that's the way you need to do it. It's really just to kind of spark interest and make you understand like how people are deploying NGINX as an API gateway. And it's going to be different depending on your organization, right? So there's the traditional edge gateway deployment, this is probably the most commonly seen API gateway pattern that we see. It's very traditional. It follows the typical application delivery controller architecture, where you have a single API or maybe multiple APIs, monolithic APIs. These are usually older applications that you're trying to expose. And you might be using an ADC, something like an F5, or you might be using NGINX there, or you might be using a cloud level load balancer, or maybe you're doing something customizable. But really that edge gateway is doing pretty much everything, right? It's doing TLS termination, right? It's doing authentication and authorization. It's doing request routing, rate limiting. It's protecting that stuff from a DDoS. And then it's also providing load balancing. And it might be doing something like request response manipulation, right? Where someone's trying to post XML and you don't like XML, you want JSON. It might be doing something like that. But it's really acting as a man in the middle and really as a gateway, reverse proxy / load balancer. And it works really, really well with old monolithic applications. But when we start introducing new architectures, as you guys know, nothing stays the same, and services are starting to get smaller and more distributed, especially in cloud environments, right? They might sit completely not next to each other, right? And so as you start introducing these little microservices, it's great if you just need to publicly expose a service and you can continue with the same order of business. It's going to provide you with this extra layer of facade routing where the client is completely unaware that you're running your new services in Kubernetes and your old services are running on Apache. So it's really provides still that single layer. But the problem comes in is when these microservices or these old monolithic applications need to start talking to each other, right? If they're talking directly to each other, then they're not getting load balancing. They're not getting authentication and authorization. They're not doing any TLS. They're not load balancing. And there's just this kind of like missing link. And so what we see is a lot of customers are instead moving to a pattern somewhat like this. This is what we call a two-tier gateway. The cool thing here is you can start to have a separation of roles of what the gateways are going to be doing. And so what we do is we say, hey, okay, we have a layer that's doing security. That's all it's really doing is it's controlling, it's offloading TLS, right? It's controlling who's authenticated to even go past that edge still. And then it's providing a central logging place where it can keep track of edge layer, connections and requests. And it might be doing something like tracing injection, like if you're doing open tracing or, in general, like if you're trying to like take a bunch of metrics from it and push it into Prometheus or some other monitoring solution, it's really doing that edge level work. And then you have a separate layer that's sitting behind that is doing authorization. So it's already gone through a layer that says, hey, I'm allowed to get further into the network. And at this point, we have a separate layer that can say, all right, well, what is that person actually authorized to do? That's usually done by the form of headers or maybe like a session token or something like that gets passed on to the next layer. And then NGINX can look, or whatever API gateway I should say that you're using, should be able to look at that and say, hey, what's authorized, right? And then also it should have some way to do service discovery, right? Because most likely service D, E, G, and H and F are really robust and probably coming down, going up. And so it needs a way to be able to actually communicate with those containers, or hopefully it's something like Kubernetes where you can talk directly to it. And it also needs to load balance, right? So you have this separation. And this is really good if you have services that are kind of thrown, like again, dispersed kind of all over the place. But there is some issues with this. And it really comes down to if you have a lot of teams that are managing different environments and different applications. If everyone's trying to make changes to the routing gateway at one time, it starts to get wild, wild west a little bit, especially the more teams that you have. You start pushing too many changes there. If one team makes a change that is impacting other applications, you can start to run into some issues here. And so another solution is to actually go to a pattern like this. We call it the Microgateway pattern. It is one actual advanced layer that you go where you actually have dedicated gateways that can be managed by individual teams. So the team that's working on API D, E, and F can have their own instance, and they can actually manage that team, right? I think we're starting to see this more and more, is that the move to DevOps, it used to be that operations handled all of the applications, and I think now a lot of the developers are being empowered to actually handle their infrastructure. And so they need their own dedicated load balancer to do what they need to with at any time, right? Change the authentication type, change the access control rules. Whatever it is, they need to be able to manage it. And so here we can do TLS termination still at the edge. We can do routing at the edge. And then we can do rate limiting as well. We can impose some like access control there, some DDoS protection. And then these individual instances or micro gateways can do load balancing. They can do the service discovery because there's a lot of need for that still in this scenario. And then they can do their own authentication. They can handle their own authentication piece. And so instead of service E having to talk to directly to service F, it can go through the actual micro gateway to gain access. And so this is really, really good, again, with north-south traffic, okay? When services are coming straight down into the service, there's no issue. What we start getting into with east-west traffic is services want to start being able to talk a little bit more directly. And as I showed you earlier, the main issue with this is service E needs to know how to reach service F's gateway, okay? So where do you actually put that policy, or where do you put that configuration? Do you use DNS? Do you use host files? How do you actually have service E obtain authentication credentials to be able to access F? You probably need to have a pretty strong IDP where it can actually go out and fetch tokens as needed. And then you need a really solid security department that can keep track of what tokens are flying around and how long they're sitting out there. So it does get a little iffy in this kind of scenario. And then the other thing is, like, what if service E and F both have different authentication schemes that they use, right? You start to have to consider that maybe some of these teams need to get on the same page about what kind of, or maybe a standard of what kind of authentication they're going to use and how they want to publish those APIs. So it does get a little difficult to manage who manages policy and who sets that E can talk to F and how often he can query the API. And you also run into the thing where each particular micro gateway has its own set of performance monitoring and metrics that it's gathering. And so for this, you need a really, really strong central place to store all of those metrics and to store the performance monitoring and the analytics piece. And then you also need really solid monitoring, right? I guess you really need monitoring with all of these, but I think it's even more important in this type of environment so that, if one of these pods goes down, you can actually be aware and recover from that and have some kind of fail-safe, right? So again, E usually needs to have some kind of service discovery integration. It needs to know how to reach the individual micro gateways that it needs to talk to. And it also needs to obtain credentials probably some way. Unless you're in some kind of like DMZ where Wild Wild West, anything can go. At this point, you really need to think about that. And then you have to think about that this micro gateway also starts to become not so micro anymore because it has to have a full configuration based on whatever rules and routes that you're trying to configure, right? And so what we're starting to see is a very large adoption of what we call the sidecar deployment or the sidecar gateway, or you guys might know it as like something like service mesh. And this is the idea that you can think of each particular NGINX instance or gateway instance as a separate pod or container. So they're actually sitting in next to each other. And this allows us to do a sidecar deployment of a proxy. And it can be useful because services can talk directly to, you're actually doing outbound load balancing. So the service is going back out through a proxy and then getting redistributed to another connection. but it is very useful because you can do TLS termination as well, all the way up into the container. You can also easily distribute because if you have a proper sidecar proxy that can fit, it's usually a pretty small footprint. So you do have to consider size of the actual container as well. You're trying to keep your containers as non-bloated as possible. And so there's definitely plus and minuses to having something like this, but it also can get more complex for a configuration standpoint because you do have to start thinking about each particular one of these has its own unique NGINX configuration. You need to make sure that configuration is in sync all the time, right? Especially if Service D, if you distribute a new version of Service D, you got to make sure that the NGINX config is the same, and you got to make sure that Service D's service container is also the same as well. And so there's a lot of scheduling issues that you have to think about this. So scheduling, configuration, and just orchestration can be a little bit of a nightmare in this. So the idea is here, you have an edge gateway that's doing TLS termination, it's doing authentication, it's doing the logging, the tracing injection, and then you have these little sidecar proxies that are doing outbound load balancing and doing service discovery integration usually built into there. And you're probably doing the authentication right then and there, and you will probably have a defined authorization as well somewhere in there that is checking to see what access control you have between the containers as well. So it's a lot to keep track of. And so what we're seeing a lot of people are doing is looking at something like a service mesh, right? And the promise here is that the service mesh is going to allow multiple DevOps teams to actually tie into the control plane using role-based access, and allows them to configure each individual NGINX using the service mesh control plane. And it takes away a lot of that heavy lifting that you have to do, but it does promise a lot. And we don't see a lot of customers that are doing this in production yet. There are, but we feel this is definitely the wave of the future. And that's why we've developed our service mesh module. And it's definitely the wave of the future. And so with that in mind, like if you want to try to stay away from the complexity and we go back to the actual two-tier gateway approach, it can definitely manage and it can perform very well in most environments. But some people would say that it's a classic hub and spoke type architecture, and you do have to consider that there might be a bottleneck. But if you actually think of these actual services as external clients, we've solved that issue with concurrency a long time ago, and it's really not a problem. NGINX can handle a large amount of connections. I think each particular, it used to be 10,000, right, per server. And with proper configuration, you can scale NGINX to handle millions of connections per second, right? And so just a recap of the patterns. So the edge gateway, it's really, really good for monoliths. If you have a centralized governance, it's not good if you want to do a lot of changes. If you're doing frequent changes, if you have DevOps teams that are owning those microservices and owning the deployments for those, it's probably not the choice for you. However, if you have a two-tier gateway, it's very flexible. It has independent scaling functions, but it lacks the distributed control. So if you have lots of teams that are trying to manage the gateway layer, that's probably not the solution for you. You might want to look at the micro gateway layer. This gives empowered DevOps teams to manage their own gateway, their own reverse proxy, and it provides high frequent updates because they can change their control plane or their data plane as much as they want, and they're only going to impact their service, right? They're not going to impact other services. But it's very hard to achieve consistency, and there's definitely a lack of security control in this layer here, okay? And so the more cutting edge solution is to do something that is like a sidecar gateway where it's policy-based, East and West traffic, and you can have strict authentication requirements in that scenario, but you have this control plane complexity that really can get confusing fast, and you really have to have that under control, and monitoring is very, very important in that layer as well. So now real quickly, I want to talk about how NGINX can help. So at the core, NGINX is a compact and high-performing reverse proxy and a gateway. It provides this layer 7 data plane. That's what it's always been from the the sweet spot is NGINX has been good at layer 7. It also is great at connection handling, right? So as far as that, you don't have to worry about that. It's very scalable. For NGINX Plus specifically, we have an API that allows you to configure your upstreams and scale them as needed. And then we also have DNS functionality built in so that we can query SRV records. So if you're using Kubernetes services, or you're using some kind of service discovery tool that supports DNS, we can query that. We also have built-in authentication and authorization directives. Most importantly, we have JSON Web Token support, where we can be the authority on the key file, and we can actually decrypt or validate the token, and not only decrypt the token, but actually decode the token into variables. And then we also have auth requests, which can support some older mechanisms that you might have for authentication. And it definitely provides insight with an API. We have an API that exposes a JSON object with metrics, and it also has a very robust logging. If you've ever logged with NGINX, you know you can log any variable and gain access to that. And depending on how you're forwarding that stuff, you can see pretty much anything you want from that proxy layer. And it's link-based, so that's probably the greatest thing, is it can be public, private cloud, no problem at all. And a lot of actual competitors of NGINX have actually built their platform around NGINX. If you look at all of these are all platforms that have actually used NGINX open source as a building point for the API gateway. And more importantly, when we set out to create our API management plane, we wanted to do it the proper way. We wanted to have the data plane, which is NGINX Plus, as the actual gateway. And then we wanted to build the controller, which would be completely separate, manage the control plane, and be completely independent of each other. So if the control plane has issues, it does not affect the API gateway. So it's high performant in that sense. No matter where the API gateway is deployed, it doesn't matter. It can handle north, south, and east and west traffic, and there's no additional need for additional databases or software components to really properly route your traffic. And it also doesn't rely on any third-party scripting. Everything is built into the NGINX configuration. And it has a very, very small footprint, because NGINX, I think the base tar is something like 3.4 megabytes, 3.5 megabytes. And then the smallest container that I've seen is about 32 megabytes. So it's very, very small, fits well in Docker, and it can easily be deployed anywhere. And so the control plane, which is our API management, it allows you to create and publish APIs, define the policy for those APIs, and also push those configurations out not only easily from a single pane of glass, but also with the best practices. We're going to recommend the best settings for your environment. There's going to be some defaults there that you can just, hey, this is what we recommend. And it's going to provide you that high-level overview of all of your instances for API health and performance monitoring, and it also provides alerting. And then these last two tabs are things that we're starting to focus on, which is our dev portal. We're going to have a dev portal coming soon to be able to allow onboarding and documenting of APIs. Right now, that's something that's coming soon. And then also, we're trying to increase the amount of analytics in the API, or to assess API, not only consumption, but also value and performance. So you'll see that as we scale the API, we'll keep track more and more metrics around those three things. So thank you. What kind of questions do you guys have? Any questions at all? Yep. Do we have a microphone? Thank you.
Oh, thank you so much for the session. So how much of this gateway stuff can NGINX do on an open source basis as opposed to NGINX Plus?
Yeah, definitely a lot of it. So as I mentioned before, all the vendors that I showed you are actually built it on open source. Depending on the vendor, they may have used some scripting language to accomplish some of the stuff that's in our commercial product. So there's definitely some heavy lifting that might need to be done either in Lua. If you guys were in the last talk, there was a lot of stuff that he did for authentication and authorization in Lua. We also have JavaScript. But a lot of the stuff is native, like the rate limiting, the connection limiting, auth requests. We don't have JSON Web Token as NGINX Plus only. A lot of the monitoring and the APIs are NGINX Plus only. So it just depends. I mean, a lot of companies, like I said, might build it around there. Depends on if you're a build shop or a buy shop. I can see both being feasible. Yeah, thank you.
Thank you.
Yep, another question?
Thanks for the session.
Yeah, no worries, thanks.
So you spoke about reverse load balancing. I would assume there would be a need for shared state across all those load balancers, and that's not an easy problem to solve. I did attend the service mesh session as well.
Oh, great.
Is that based off the same product?
Yeah,
Or-
so, well, the service mesh session is actually, I don't know what they're using in the demo. They could be using NGINX. I think, yeah, they're using NGINX Plus. They might actually know it's open source. It's NGINX open source. Yeah, so to answer your question about outbound load balancing, there's two ways that we try to circumvent issues with that. One is we have least time load balancing in NGINX Plus. So we can actually route to the container that's responding with the fastest response time, which can really start to even things out pretty well. It'll keep track of all of the services. But the problem is, yeah, when you have multiple instances that aren't keeping track of each other, that's when you start to run into issues. And so a lot of people might use DNS or some kind of other solution to, instead of routing that traffic directly to a pod or a container, it would just route it to a DNS entry, and then the DNS entry would make a decision on global availability or whatever SaaS they're responding.
Thanks.
Yeah, no problem. Any other questions? Cool. Well, thank you guys for coming. I really appreciate it.